While solving word problems on differential equation, the first thing we have to do is to read the problem carefully, understand correctly the things given in the problem, things to find out, frame the differential equation according to the things given, solve the differential equation, whether it is a general solution or particular solution according to things to find. Let us understand all this by solving a few representative word problems on differential equations. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. We have to find equation of curve passing through origin 0, 0 and whose differential equation is dy by dx equals e raised to x sin x. Since the curve passes through origin, we are given x equals 0 and y equals 0, which means we have to find particular solution of this differential equation. We rewrite the differential equation as dy equals e raised to x sin x dx. Here functions of x are with dx and constant 1 is with dy. So the variables have been separated. Now we will integrate them. So integral 1 dy equals integral e raised to x sin x dx. Here there is product of two functions. So we have to integrate this by the method of integration by parts. Integral of 1 dy will be y equals, we name this integral as I, as 1. We will solve integral I, so it will be integral sin x into e raised to x dx. It will be first function sin x into integral of second. Integral of e raised to x is e raised to x minus integral of derivative of first. Derivative of sin x is cos x. Integral of second, integral of e raised to x is e raised to x dx equals e raised to x sin x minus, here also there is a product of two functions, so this integral also we have to solve by method of integration by parts. So again first function cos x into integration of second, integration of e raised to x minus integral derivative of cos x minus sin x into integration of e raised to x. So I will be e raised to x sin x minus e raised to x cos x. Minus into minus will be plus, and again because of this minus sign it will be minus integral e raised to x sin x dx. Now we find that this is nothing but this integral which we have named I. So we write here I equals e raised to x into sin x minus cos x minus I. This will be 2I equals e raised to x sin x minus cos x, or I will be half e raised to x into sin x minus cos x. Now using this value of I in equation 1, general solution of this differential equation will be y equals half e raised to x sin x minus cos x. We haven't added yet the constant of integration, so we will add it here, plus c. Now this is general solution of the differential equation. For finding particular solution, we will use x equals 0 and y equals 0 to find value of c. So we write in this equation 0 equals half e raised to 0 into sin 0 minus cos 0 plus c. This equals half e raised to 0 is 1, sin 0 0 minus cos 0 1 plus c. 0 equals minus half plus c, that gives us c equals half. Now by using this value of c, here we will write equation of the curve as y equals half e raised to x into sin x minus cos x plus half. In the simplest form, this equation will be multiplying by 2, this will be 2y and bringing this one on the left hand side, it will be minus 1 equals e raised to x into sin x minus cos x. So this will be the solution of the equation of required curve which passes through origin. For the differential equation xy dy by dx equals x plus 2 into y plus 2, find the solution curve passing through the point 1 comma minus 1. To find the solution curve, we first have to find out general solution of this differential equation, and after that from 1 comma minus 1, putting x equals 1 and y equals minus 1, we have to find the particular solution, which will be the equation of this curve. First, we will separate the variables. We write dy by dx equals x plus 2 upon x into y plus 2 upon y. We will multiply by dx and divide by y plus 2 upon y. So in the next step, it will be y upon y plus 2 dy equals x plus 2 upon x dx. Now we will integrate. Integral y upon y plus 2 dy equals integral x plus 2 upon x dx. Integral, we write y as y plus 2 minus 2 upon y plus 2 dy equals integral x plus 2 upon x dx. Integral y plus 2 upon y plus 2 is 1 minus 2 upon y plus 2 dy, which equals integral x upon x 1 plus 2 upon x 2 upon x dx. After integrating, y minus 2 log y plus 2 equals x plus 2 log x plus c. Y minus x minus c equals 2 log x plus log y plus 2, which is log x square y plus 2 square. So y minus x minus c equals log x square into y plus 2 whole square. Now this is the general solution of differential equation. Now by putting x equals 1 and y equals minus 1, we will find the value of c. So minus 1 minus c equals log 1 square is 1, minus 1 plus 2 is 1 square. This is log 1 and log 1 is 0. So c will be minus 2. Substituting c equals minus 2 in this general equation, we will get solution curve passing through 1 minus 1 as y minus x minus c will be plus 2 equals log x square into y plus 2 whole square. Find the equation of a curve through the point 0, minus 2. Given that at any point x, y on the curve, the product of slope of its tangent and y coordinate of the point is equal to the x coordinate of the point. We know that slope of the tangent at point x, y is dy by dx multiplied by y coordinate, that is y. It equals to the x coordinate of the point, that is x. So this is the differential equation that we have to solve. So first we will find general solution, and after that from this point 0, minus 2, using x equals 0 and y equals minus 2, we will find the particular solution. So the first thing is to solve this differential equation. For separating variables, we write y dy equals x dx, function of y with dy, function of x with dx. Variables have been separated. Now integrating y square upon 2 minus x square upon 2 equals constant of integration c, which is also the arbitrary constant. Y square minus x square equals 2c. This is general solution of this differential equation. Now we will substitute x equals 0 and y equals minus 2 in this equation and find the value of c. So minus 2 square 4 minus 0 square 0 equals 2c. So c will be 2. Now we will use value of c in this general equation and get the particular solution. Y square minus x square equals 2 multiplied by 2, 4. So this is the equation of this curve which passes through point 0, -2. At any point x, y of a curve, the slope of tangent joining the point of contact to the point -4, -3. Find the equation of the curve given that it passes through -2, 1. We name point x, y A and point -4, -3 B. Now it is given that slope of the tangent, which is dy by dx, is equal to twice, that is 2 times, the slope of segment joining x, y and -4, -3, which will be difference between y coordinates, that is y minus -3 upon x minus -4. So this will be dy by dx equals 2 y plus 3 upon x plus 4. So this is the differential equation that we have to solve. We will find general solution and after that particular solution. For separating the variables, first we will cross multiply x plus 4 dy equals 2 into y plus 3 dx. Next we will divide this dx by x plus 4 and divide this dy by y plus 3. dy upon y plus 3 equals 2 upon x plus 4 dx. Function of y with dy, function of x with dx, variables have been separated. Next we will integrate log y plus 3 equals 2 log x plus 4 plus, in place of constant of integration we will write log c because there is log in rest of the terms. This will be log y plus 3 equals log c into x plus 4 whole square. Y plus 3 will be c x plus 4 whole square. Now this is the general solution which will represent family of such curves. Since this curve passes through point -2, 1, we will use x equals -2 and y equals 1. So this will be 1 plus 3 equals c into -2 plus 4 is 2, 2 square is 4. So c will be 4 upon 4, 1. So the particular solution will be from this y plus 3 equals 1 multiplied by x plus 4 whole square will be x plus 4 whole square. So this will be the equation of this curve which passes through -2, 1. The volume of a spherical balloon being inflated changes at a constant rate. That means if V is volume of balloon, then rate of change of volume with respect to time, that is dV by dt, is constant, say k. Now volume of balloon is 4 upon 3 pi r cube, where r is radius of balloon. If initially its radius is 3 units, initially means when time is 0, radius was 3 units, and after 3 seconds, that means when t is 3, radius is 6 units. We have to find radius r after t seconds, which means when time was t. We have the differential equation dV by dt equals k, which will be, after putting the value of v, d by dt of 4 upon 3 pi r cube equals k. This will be 4 upon 3 pi into 3r square, and since we have to derive with respect to t, we have to multiply here by dr by dt, which is equal to k. Cancelling 3, this will be 4 pi r square dr by dt equals k, which is 4 pi r square dr equals k dt. Function of r with dr and constant with dt, variables have been separated. Now integrating 4 pi r cube upon 3 equals kt plus constant of integration c. 4 pi r cube equals 3 times kt plus c. By using the initial condition t equals 0 when r equals 3, we write 4 pi 3 cube equals 3 k into 0 plus c. 27 4s are 108 pi equals 3c, or c equals 108 pi upon 3, 36 pi. Using second set of conditions t equals 3 when r equals c. In this equation 1, we write 4 pi 6 cube equals 3 k multiplied by 3 plus c. 6 cube is 216. 216 multiplied by 4 is 864 pi equals 9k plus 3c. 864 pi equals 9k plus 3 multiplied by value of c is 36 pi. So 3 into 36 pi equals 9k plus 108 pi. 9k will be 864 pi minus 108 pi, 756 pi. After solving further, it gives k equals 756 upon 9, 84 pi. We will substitute these values in the equation which we have earlier found out. 4 pi r cube equals 3 times kt plus c. Substituting the values of k and c, this will be 4 pi r cube equals 3, 84 pi t plus 36 pi. 3 multiplied by 12 pi into 70 plus 3. So r cube will be 3 multiplied by 12 pi into 70 plus 3 upon 4 pi. Cancelling pi, 4 ones are 4 threes are equals 9 into 70 plus 3, 63t plus 27. So r will be 63t plus 27 to the power 1/3, and this will be the radius of the balloon after t seconds. In a bank, principal P increases continuously at the rate R% per year. We have to find the value of R if rupees 100 doubles itself in 10 years. We are given principal increases continuously, that means dp by dt equals at the rate R% per year, that is R upon 100 times p the principal. So this is the differential equation that we have to solve. For separating variables, we write dp upon p equals r upon 100 dt, function of p with dp and constant with dt. So variables have been separated. Integration of 1 upon p log p to base e equals r upon 100 into integration of 1 dt, that is t, plus constant of integration c1. This in the exponential form will be p equals e to the power rt upon 100 plus c1. It is given that initially when t equals 0, principal p was 100. Using these values in this equation 1, 100 equals e raised to 0r upon 100 will be 0 plus c1, so that will be e raised to c1. We name this 2. It is given that rupees 100 doubles itself in 10 years, which means when t is 10, principal doubles means p equals 2 multiplied by 100, 200. So equation 1 becomes 200 equals e raised to 10r upon 100 into this will be e raised to c1, so which is e raised to r upon 10 into 100, because e raised to c1 is 100 according to equation 2. Cancelling these two zeros, e raised to r upon 10 is 2, r upon 10 equals log 2 to the base e, which is exponential form to logarithmic form. And in the problem, value of log 2 to the base e is given as 0.6931. So r will be 0.6931 multiplied by 10, 6.931. So r, that is rate of interest, will be 6.931%. In a bank, principal increases continuously at the rate 5% per year. An amount of rupees 1000, that is principal rupees 1000, is deposited with this bank. How much will it worth after 10 years? It is given that e to the power 0.5 is 1.648. Principal increases continuously at the rate 5% per year, which means rate of change of principal, that is dp by dt, is 5% of principal p, which is 5 upon 100 p. So this is the differential equation we have to solve. We separate the variables by cross multiplication. So it will be dp upon p equals 5 upon 100 dt. Function of p with dp, constant with dt. Variables have been separated. Now we integrate. Log p equals 5 upon 100 is 1 upon 20 plus constant of integration c. In exponential form, this will be p equals e raised to t upon 20 plus c. By laws of indices, this will be e raised to t upon 20 into e raised to c. Initially, that means when time t is 0, principal was rupees 1000. Using these values in equation 1, 1000, e raised to 0 upon 20 is e raised to 0, that is 1, into e raised to c. We name this 2. We have to find how much will it worth after 10 years. We have to find the principal after 10 years means when t is 10. So putting these values in equation 1, it will be p equals e raised to 10 upon 20 into e raised to c, but e raised to c is 1000. So we write 1000 here, which is 1000 multiplied by e raised to 10 upon 20 is e raised to 0.5, the value of which is given here 1.648. That will be, after shifting the decimal to 3 places on the right hand side, it will be rupees 1648. So the principal after 10 years at the rate of interest 5% per year will be rupees 1648. In a culture, bacteria count is 100,000 or 1 lakh. This number increased by 10% in 2 hours. In how many hours will the count reach 200,000 or 2 lakhs if rate of growth is proportional to the number present? Let y be the number present at any given time. Now rate of growth is proportional to the number present. So rate of change of y with respect to time dt proportional to the number present y. dy by dt equals ky, where k is constant of proportionality. dy upon y equals k dt. Function of y with dy, constant with dt. So integrating log y equals kt plus c. We name this 1. Initially, when t equals 0, let the quantity be y0. So log y0 equals k into 0 0 plus c, that is c. c equals log y0. So general solution 1 becomes particular solution log y equals kt plus log y0. Taking log y0 to the left hand side, log y upon y0 equals kt. We name this equation 2. It is given that there is 10% increase in 2 hours, which means y equals y0 plus 10% of y0, 1 plus 1 upon 10 y0, y equals 11 upon 10 y0. That gives y upon y0 equals 11 upon 10 when time t is 2 hours. We will use these values in equation 2. So it will be log 11 upon 10, that is 1.1, equals k into 2, that is 2k. So k will be half log 1.1. Now we will substitute the value of k and value of c in equation 1. T will be 2 log y upon y0 upon log 1.1. It is given that number of bacteria increased from 1 lakh to 2 lakh, which means y equals 2 times y0. Substituting this, time required for this increase in bacteria count will be 2 log 2y0 upon y0 upon log 1.1. Cancelling y0, this will be 2 log 2 or log 2 square or log 4 upon log 1.1. So this much time will be required, log 4 upon log 1.1, to increase the bacteria count from 1 lakh to 2 lakh in 2 hours. If you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.